Hello there, this is an Algebra 2 video. It is Chapter 6, Section 6, and today we are discussing rational exponents. And so we have, like before, just want to remind you that when we think about rational exponents, b has to be a real number and n has to be a positive integer. And as long as that happens, then if you write b to the 1 over n power, which is a fraction, so we think of rational exponents, you think of fractional exponents, but basically you can write it. A rational exponent as a radical, and that's the whole point. Keeping in mind that the n, which is the bottom of the fraction, is the index, and the 1, which is the top of the fraction, is the exponent on the inside of the radical. So in example 1, real simple, real straightforward. To simplify, they want us to be able to go back and forth between radical form and exponential form. So it says here, write x to the 1/6 in radical form. So all we have to do is remember, like I said up here, the number on the bottom is always going to be the index. So that's 6. So it's going to be the 6th root of x to the 1 power, because the top number is a 1. So 6th root of x to the 1 power, or you could just write 6th root of x. No need to put the actual 1 there, but there you go. All right, this will be our answer there. In part B, the ones go the other direction. And so because we have our variable z, this is e to the 1 power, so the 1 goes on top. On the bottom, you put the index, which is a 4. So z to the 1/4 is exponential form. And that is as complicated as it gets. So you can try to do it yourself, number 1. Again, going back and forth between radical and exponential form. In part 2, they want us to evaluate the expression. And so a lot of times it is helpful for you to write it in a radical form because it's more familiar to you. So remember that when you have a negative exponent, that means that you have to flip it. So this would actually become 1 over 81 to the 1/4 power, the positive 1/4 power. And then you'd want to write that as a radical. So it would be 1 over, and this would be a 4 because that's on the bottom, the 4th root of 81. So we're looking for something raised to the 4th power that would give us 81, and that number would be 3, because 3 times 3 is 9, and 9 times 3 is 27, and 27 times 3 is 81. So in the end, you get the 4th root of 81 is 3, so the answer is 1/3. In part B, very similar, you get 216 to the 2/3 power, which means that the number on inside the radical is 216. The number on the bottom is the index, and the number inside here is a 2 because the top is a 2. So 216 squared. But you can also write 216 as 6 cubed. So I'm going to go, I think it's 6 to the 3rd power. Yes, it's 216. So 6 cubed. And then squared. So what I'm going to do, actually, I just saw what I can do here. I'm rewriting so that's fine. I'm going to keep it like that so I can show you what I'm doing here. There's different ways of solving this. This is the way I'm going to do it. So 216 is the same thing as 6 cubed, but that's squared. So that means that it's 6 cubed times 6 cubed. And we have this little guy that we can separate like that. So it basically means that you're going to get, that's going to cancel, that's going to cancel. So you're going to get 6 times 6. So in the end, the answer is 36. Not the only way that you could do it, but it is a way, and it's the way that I did it. So I do want to show you something else you could have done. Is from the get-go, you could have made 216 6 cubed, and then to the 2/3 power. And since we know that you have a power raised to a power, this is going to be 6 to the 3 times 2/3. And then 3 times 2/3 would have been just 2, because you would have gotten 6 divided by 3, which is 2. And that's still 36. So I'm not sure which way is easier for you, but both of those ways will work. So here's do-it-yourself number 2, and then we will go on to generalizing this. I said earlier that the top number was a 1, but it could be like in part B, it could be a different number. So just in general, the top number goes on the inside as the exponent, the bottom number goes as the index. All right? So we have an example here, and it's asking us to refer back to the beginning of the lesson. And if you actually open your book and go to the beginning of the lesson, there's a formula given, but I've written it here for us. It's C equals C times 1 plus R to the n, and it tells us that this formula is used to estimate the future cost of an item due to inflation. So capital C right here represents the future cost, the little c represents the current cost, and then R is the rate of inflation, and N is the number of years. So based on that, we're going to do this example. Suppose a video game system costs $309 now. So that's going to be the current cost here. So we're going to plug that in. $390 now. 1 plus the interest rate is 5.3%, but you always want to write that in as a decimal. So we need to move the decimal over 2 places, or divide it by 100, either way. That's 0.053. And then it says how much would the price increase in 6 months? But T is time in years. So 6 months of a year is basically half the year. So our T is going to be to the 1/2 power. All right? So that's basically how we do that. So we're going to go 1 plus 0.053 is 1.053 to the 1/2 power. So you want to be really careful here. A lot of times people will multiply 390 times 1.053 and then raise it to the 1/2 power, but that's not correct. PEMDAS actually says to do exponents first and then multiply. So multiplying this first would be the wrong thing to do. You want to do exponents first, so we want to go 1.053 and then raise it to the 1/2 power, which is the same thing as the square root, but you can use the caret key to raise it to the 1/2 power, and this is going to be 1.026 roughly. And then that times the 390. So once you do the square root of that, then you can multiply that by 390. And then your answer will be 400.20. And we are looking for cost here, so you want to just leave it at 2 decimal places. So after 6 months, the price will increase to $400.20, but they're asking how much the price increased. So if the price was $390, we want to take 400 and subtract the 390 that it was, and it increased $10.20. So $10.20 is how much the price increased. Make sure that you answer the right question. All right, so then that is your do-it-yourself number 3. And then we have a couple more examples for you. In example 4, I just want to reiterate here that all of the properties for powers that we learned in 6.1 still apply to rational exponents. In other words, when you have a squared times a cubed, you add the exponent. So when you're multiplying the same base, you add the exponent. When you're dividing, you subtract the exponent. Negative means you move it down. All of that stuff still applies to rational exponents. It's just that people don't like to do it because, well, let's just face it, most of the time you hate fractions. But in this case, we have the same base being multiplied, and so what we want to do is to actually add the exponents. So a to the 2/7 times a to the 4/7 is a to the 2/7 plus 4/7, which is a to the 6/7. And that would be your answer. And then for part B, we get a to the negative 5/6, but to make sure that the exponent is not negative, you get 1 over b to the 5/6 power. And what you have to remember is that that's a radical. That literally means 1 over b to the 5th power, and it's like the 6th root, like that. And we already said before that you can't have a radical on the bottom. So you didn't have that problem in part A because this is not on the bottom of a fraction. But the 5/6, the b to the 5/6 is on the bottom of the fraction. So you can't have that. So you do have to rationalize that one. So what you want to do is times it by b, the 6th root of b. You can't really see it on the top there, but, and the reason why I'm just going to multiply by 1b is because I already have 5 here, b to the 5th, times b is b to the 6th. So that's going to give me the 6th root of b to the 6th on the bottom. On the top, I'm just going to have 1/6 root of b. All right, and then these are going to cancel. So my final answer will be b. I'm going to go back to the fractional notation, or the rational notation, sorry. So the 6th root of b is b to the 1/6 power. And on the bottom, you just get b to the 1 power. All right, so b to the 1/6 power over b is our final answer. So now, if you would do it yourself number 4, which is right here on the bottom, then we will move on to our last example, example 5, where again we are just being asked to simplify radical expressions. And so I have a 4th root on top and a square root on bottom. So I'm going to go ahead and write this as a rational exponent to make it easier for myself. So 27 to the 1/4 power over 3 to the 1/2 power. And then I know that 27 is 3 to the 3rd power. 3 to the 3rd power is 27. So I'm going to write this as 3 to the 3rd power to the 1/4 over 3 to the 1/2. Okay? So that means I'm going to get a power to a power. So that's 3 to the 3/4 power, which is 3 times 1/4 over 3 to the 1/2. And now what I've done is I have the same base and it's dividing, so I can use the property that says I can subtract the exponents. So I'm going to get 3 to the 3/4 minus 1/2. All right, and so basically 3/4 minus 1/2 is 1/4. So at the end of the day, I get 3 to the 1/4. And basically, since I started off in radical notation, I want my answer at the end to be radical notation. So it'll be the 4th root of 3. Alrighty. So now we're going to go to part B. And the cube root of 64. So let's see here. I know that 4 to the 3rd power is 64. And then for my z, I'm going to put z squared to the 3rd power because 2 times 3 is 6. And remember, I want all of these to be 3s because my index is a 3. So then I will get cube root of 4 cubed times cube root of z squared cubed. And so then they'll cancel and give me a 4. And they'll cancel and give me a z squared. So I get 4z squared for my answer for part B. Nice and easy peasy Japanesey. Alright, now for the last one, I want to remind you that it's probably easier for you to write it into radical notation, but basically what's happening here is x to the 1/2 is the square root of x. If you remember, the index is a 2 and to the 1. So it looks a lot scarier when you see it like this, but this is 3 root x plus 2. And when you look at it like that, it just becomes a really basic rationalization problem. So you want to multiply by the conjugate, which is 3 root x minus 2 over 3 root x minus 2. Okay, so then here I'm going to FOIL on top. And root x times 3 root x is 3 root x squared. 3 root x squared. Now notice I'm not squaring the 3, I'm just squaring the root x because it's root x times root x, so root x squared. Outside times outside is root x times negative 2, so negative 2 root x. Inside times inside is negative 6 root x. and last times last is plus 4. Okay? So then that can get simplified because this root x squared is going to cancel. So now this is just 3x. Okay? So we've got negative 2 root x and negative 6 root x. And these are like terms because they both have a root x. So negative 2 and negative is negative 8 root x and then plus 4. So that's the top. 3x minus 8 root x plus 4 is on top. And on the bottom, you remember that when we have conjugates, a plus b, a minus b, you get a squared. So we're going to divide that by 3 root x squared minus b squared. So on the bottom, you're going to get, remember now you do have to square the 3 and the root x. So now it's 3 squared is 9. Root x squared is just x. And then minus 4. So on the bottom, you get 9x minus 4. So when we combine, our final answer will be the 3x minus the 8 root x plus the 4. Divide all of that by 9x minus 4. And this is your final answer. 3x minus 8 root x plus 4 over 9x minus 4. Alrighty, so now you will have a chance to do these 3 examples as part of this do-it-yourself number 5 question. And once you have completed this question, you will have completed your notes for this lesson. And I will see you in class. And thank you for watching.